Alright, so in this video you'll have the examples. We'll try to do them pretty cleanly and quickly. So example 1, calculate the distance between 4, 9 and negative 2, 6 using both Pythagorean theorem and distance formula. You did the Pythagorean theorem in 611, so we'll very quickly discuss that just a tiny little bit. So Pythagorean theorem, we would need to do your right triangle. And that's 1, 2, 3, 4, 5, 6. And this is 1, 2, 3, right? So we're talking about 3 squared plus 6 squared equals c squared. All right, so that's 9 plus 36 equals c squared, which is 45. And we need to square root. So it's the square root of 45. Okay, now we can do the distance formula, which is a little bit more complicated, but it's not too bad. So the only thing that is going to be set up different is you're going to have the square root of your x2 minus x1. Now here's the good news. It's not going to matter which one you call x1, y1, x2, y2. So we'll do this as x1, y1, and this as x2, y2. Okay? So the way the formula goes is it's x2 minus x1. So that's going to be 4, and then minus negative 2. So minus negative 2 squared plus y2 minus y1 squared. So that would be 9 minus 6. Okay, you should see some things start to stand out when we do this and simplify a little bit. So 6 squared plus 3 squared. So this part goes back to this part. Okay, 6 squared plus 3 squared, 3 squared plus 6 squared. Same thing, right? So we simplify that, and we get 36 plus 9, so we end up getting the square root of 45 again. Okay? And you would, of course, change that to a decimal, approximate it out. For the sake of time, we'll move on with that. I'm confident you can do that now. All right, so let's look at example 2. So that we proved that distance, right, using those formulas. Now, it says determine, using algebra basically, if these two lines are parallel. This is a very simple test. Parallel lines, if you go back and read the notes, have the same slope. I don't have to check anything else except slope, right? So I got some points here. So we go 1, 2, 3, down 2, right? So up 2, left 3, or right 3, down 2. Either way, make sure you rise over run. The slope is 2 over negative 3, or negative 2/3. Okay? Now look at the other one. I go right 3, down 2. So it's the same movement. So the second one has a slope of negative 2/3. Okay? So yes, they are parallel. All right, third example. Determine if the two lines are perpendicular. Perpendicular means that you have negative reciprocals. In other words, if m is change in y over change in x, then the negative reciprocal would be negative x over y. Okay? You flip them, get the reciprocal, and it becomes negative out front. So what we want to do is we want to find the slope of this first one. All right? So for this guy, we have our points, so go up 1, right 4. So that's 1, 4 for our slope. For this other one, okay, we are going right 1, down 1, 2, 3, 4. Okay, so right 1, down 4. So that would be negative 4 over 1. Okay, are those indeed negative reciprocals of each other? Yes, they are. So yes, indeed, these are perpendicular based on that. Okay, which means that this is a 90-degree angle. Okay? So, and again, now this one can be simplified, of course. That's the same thing as this. Okay? You would not see that written on your milestone. You would see that. Okay? If that was the answer choice. So, make sure you understand what negative reciprocals are and what they mean. They show lines are perpendicular. All right, so let's take a look at this one. A right triangle is defined as a triangle with two sides that are perpendicular. Triangle ABC has vertices given. Determine if it's a right triangle. We really only have to check one angle. Okay, it is very obvious that A and C are not 90-degree angles. Okay, the only one that we're really concerned about is this one right here. Is that enough to be 90? So I need to check the slope of this line and the slope of this line. If I can do that and prove that they are negative reciprocals, then I know they're perpendicular. Okay, so we're going to take a look at this one. We go up 1, 2, 3, 4, right 1, 2, 3, 4, 5, 6, 7, 8. So 4 and 8, that means that the slope is 1/2. Right, 4 over 8. We went up 4 and right 8. Now, from A to B, we go right 1, 2, 3, down 1, 2, 3, 4, 5, 6. Okay, so that would be -6 because we went down 6, right? Over 3. Or you think about it as up 6 and left 3. It's the same thing either way. All right. Up 1, 2, 3, 4, 5, 6. Left 1, 2, 3. So +6, -3 is a negative fraction, which comes out to -2. So -2 and 1/2 are indeed perpendicular because those are indeed negative reciprocals of each other. Okay. So that is 90. Okay. All right. So next, we're going to look at this guy. A square is a quadrilateral with two pairs of parallel opposite sides, consecutive sides that are perpendicular. So we need to make sure we're perpendicular here. All right. So we go 1, 2, 3, down 2. So, and these need to be parallel. So 1, 2, 3, down 2. So BC has a slope of -2/3. And AD, which is the opposite side, also has a slope of -2/3. All right. And then AB has a slope of up 1, 2, 3 over 2. So that's +3 over 2. And DC has a slope of 1, 2, 3 over 2, 3 over 2. All right, so that confirms our parallel and perpendicular. Now we just need to make sure they're all the same length. Now the way we can do that is, if you think about it, they were all over 3, right? 2 and 2, 3 and 2, 3. So you can do the distance formula if you want to. But if those lengths are all the same, then if you think about doing Pythagorean theorem for all of them, you're going to be doing 3 squared plus 2 squared equals c squared, which is that length here, right? And since it's the same multiplication everywhere, that's going to be 9 plus 4 is c squared. So 13 equals c squared. So square root of 13 would equal c. And it doesn't matter which of those lines you're doing, which means they all come out to having that as their length. So indeed, all 4 sides are congruent, and opposite sides are parallel, and adjacent sides that are touching at a corner, are perpendicular. Therefore, it is indeed a square. Okay, we've proved all parts to justify it being a square. All right, good deal.